Alaikum. Welcome to the lecture 1 of unit 2nd. Today's unit is uncontrolled and controlled rectifiers. What is a rectifier? And after that, I'm going to teach you what's its classification. Rectifier is a converter circuit which converts AC into DC. Or we can say that rectifiers are used to convert AC power into DC power. These rectifiers are divided into uncontrolled rectifiers, fully controlled rectifiers, or semi-controlled rectifiers. That means in this uncontrolled rectifiers, we are using diode. In fully controlled rectifiers, we are using thyristors, while as in case of semi-controlled rectifiers, we are using diodes as well as thyristors. Either we are using diode or thyristor or a combination of both diode and thyristor. That means in this rectification, we are using semiconductor devices. Now, firstly, what's this uncontrolled rectification? Now, in this uncontrolled rectification, where we are using uncontrolled rectifier, that is diode, we are converting fixed AC into a fixed DC. That means here the output DC is not controllable, or we can say here at the output we are getting that constant DC. In this uncontrolled rectification, both turning on, or we can say both conduction and commutation, that is the turning off process of these diodes, that depends upon the circuit conditions. Or we can say in this uncontrolled rectification, the output voltage does not vary for a given load or a given supply. Therefore, it's called uncontrolled rectifier. While as in case of semi-controlled rectification, where we are using diodes as well as thyristors, we are converting this fixed AC into this variable, or we can say the adjustable DC. This adjustable output voltage is obtained by changing the firing angle of these thyristors. Here, the controlled output voltage and the current are unidirectional, and the power flow is only in one direction, that's from AC to DC, from AC source to the load, AC side to the DC side. Now the third one, that is the fully controlled rectification, where we are using only thyristors. Here the output voltage or adjustable voltage is obtained from the fixed AC voltage. This adjustable voltage is obtained by varying the firing angle of these semiconductor devices or thyristors. In this case, the direction of the current remains same, but the output voltage can be reversed. This output voltage is reversed, which allows the power flow from load to the supply. Process where power flows from AC side, from DC side to AC side, is called inversion, and the converter operating under this condition is called inverter. Or we can say, with the help of this fully controlled rectifier, both rectification as well as inversion is possible. Also, we can say that the direction of current remains same, that is from AC side to DC. That means our current is unidirectional in all the three cases, and these converters are called line commutated or naturally commutated converters, because they can be turned off by the natural supply or by the AC supply. And this is the general block diagram of of a uncontrolled rectifier, where this is the source voltage, this is the diode that we are using, and here capacitor is used to produce ripple-free DC output voltage. These uncontrolled rectifiers are used in majority of the power electronic applications, such as switching DC power supplies, AC motor drives, DC servo drives, and many more. As already discussed, by using these diodes, we are obtaining uncontrolled or fixed DC, while as by using semi-controlled or fully controlled semiconductor devices, we are obtaining the variable or adjustable DC. This is the conventional AC DC voltage converters. This is the conventional method where we are using not semiconductor switches. We are using auto transformers or tap changing transformers to obtain that variable output voltage. But this suffers from the disadvantage due to the large size, weight, and cost of the transformers, resulting in the enormous amount of losses due to the use of this oversized transformer. And these disadvantages or losses are overcome by using power semiconductor devices like thyristors or the combination of thyristors or diodes. In that case, that semiconductor device or thyristor that behave like an ordinary switch, or we can say for a certain period of time the switch is closed, and then for a certain period of time it's open. Or we can say when the switch is closed, the input voltage V, the input or supply voltage reaches the load, and the output voltage becomes equal to that source voltage. Similarly, for a certain period of time the switch is off, or we can say the input voltage does not reach the load, or we can say the output voltage becomes equal to 0. Thus, instead of this complete input voltage reaching the load, this switch or phase control converter, or simply control converter, slices the input voltage and only its part reaches to the load. We are not using transformer, or we can say losses are less, or we can say efficiency is very, very high. Now, this is the classification of converters that is done on the basis of supply. If we are providing this single phase at the input side, we are saying this is the single phase AC to DC converter. If we are applying the three phase, or that means we are saying the converter is three phase AC to DC converter. For that, these single phase as well as three phase, they are divided into uncontrolled and controlled. If we are using only diodes, then that means this device is this is called uncontrolled. These are called uncontrolled converters. While as if we are using SCR and diode, these are the controlled converters. Controlled or control rectifiers are divided into half wave or full wave, or we can say one pulse or two pulse, depending upon whether we are obtaining one pulse for a cycle or two pulse for a cycle. This represents the overall classification of converters. For single phase as well as for three phase, they are divided into uncontrolled and controlled. The difference is, in case of three phase, for half wave we are getting three pulses. That means for a cycle we are getting three pulses, and for a full wave we are getting six pulse wave form. If we explain the classification on the basis of pulse number, we are saying we have one pulse, two pulse, three pulse, or six pulse rectifiers. For one pulse, we mean, and that means for a full cycle we are getting only one pulse. That is in case of single phase half wave rectifiers, we are obtaining the wave shape of this form. While as in case of two pulse, we are obtaining for a full cycle, we are obtaining two pulses, and this is the waveform is obtained in case of single phase full wave rectifier, three pulse converter, and this waveform is obtained. That means we are obtaining three pulses for a full cycle of AC input voltage, and this waveform is obtained in a three phase half wave rectifier, and this six pulse is obtained in case of three phase full wave rectifiers. Here this represents the ripple voltage, that is the change in output voltage. In case of three pulse and six pulse, this ripple voltage is lesser, which this ripple voltage is lesser, resulting in the lesser harmonic content, or we can say our waveform contains more DC.